This is the miniature friction drive that I've built. It's a drive that uses an RC motor. It uses a Hyperion motor in conjunction with a Cas Creations 85 amp high voltage speed controller. The purpose of the design was to try and keep it as compact as possible and to also keep it as light as possible, but without compromising the actual rigidity and strength of the unit itself. This is the Mark II version. The first version was a bit of a test bed and basically a proving ground for the concept. And once I was happy enough with the concept, I decided to build a more refined version of it, which is what you see right here. Basically, the way it operates is that it has an RC motor at the back, which you can just see here, which is an outrunner and uses a friction drive to actually drive against the tyre directly off the can of the outrunner itself. Now, I decided to use a Hyperion motor because it has a ring bearing which basically supports the actual outside of the actual can very well, and allows you to put a fair bit of pressure on the drive when you're pushing up against the tyre. The system incorporates a over-centre locking device which actually rides up the tyre when it's activated. The idea being that when the drive is in the off position, it actually pulls away from the tyre completely and there's no drag at all on the actual tyre itself, so the bike rides like a completely normal bike. But once you activate the drive actually climbs the tyre and then pushes harder into the tyre to give a good firm contact with the tyre. You can see here it's got a pivot method there. You can see the way it pivots. It has a stop wire stopping it going too far, and when the drive turns off, it then springs back into that position there. The drive is also designed for quick installation and removal. The installation is simply carried out by placing the drive on the back part of the frame, and it locates using these two pins here to sit against one of the frame braces, and then this main threaded pin here which a locking nut goes against to actually clamp the drive onto the back of the frame of the bike. So I'll just show you now how quickly the actual unit can be attached to the bike, and we'll give it a quick test run also. So the device is now attached to the bike, and if I pick up the back and give the wheel a spin, you can see that the wheel spins completely free from the drive itself, and essentially the bike is can still operate just like a standard bike operates. Now what we'll do is we'll give the drive a run to demonstrate the actual drive in action. I'm using a 5S battery here, so I've basically got 18.5 volts. With this type of battery, it's a 5,000 milliamp hour pack. I just plug in the two plugs. The first plug is the actual controller switch, which is just a 2-position switch. The second plug is my battery, of course. Continue the speed controller firing up. I use a 2-speed switch arrangement. The first speed gives the bike around about 20-25 kilometers an hour, which is perfect for climbing hills. And the second speed basically gives the bike full throttle. And on 5S, that's good for around about 40 to 45 kilometers an hour. And for around a 6S, I can get 50 kilometers an hour out of the bike, so that's not a bad speed out of such a small drive. In regards to the amount of power that it's drawing, I'm typically drawing around about 300 to 400 watts on the low speed setting, and in the high speed setting between probably 1200 and 2000 watts, depending on how hard I'm climbing at the time. So I'll just run the drive up now, and I'll switch just onto the low speed setting. So it's got I utilise the soft start on the actual drive. It's on the speed controller itself, and you'll see the drive will ramp up quite slowly. And so the drive picks up. Now I'll just apply some brake to simulate a hill, and you'll feel the drive go into the overlock position. And now the drive is locked in position, simulating climbing a hill. And then once I come to the top of the hill, I just simply turn the drive off, and the drive swings away from the wheel, and the bike freewheels.